This conference will now be recorded.
Good morning to all. Today our topic, comparison between Bjt and FET, bipolar junction transistor and field effect transistor. Okay. So bipolar junction transistor has a 3-terminal, 2-junction active component. JFET, 3-terminal, 2 junctions field effect transistor. So now comparison. Bjt means total name, bipolar junction transistor short form is Bjt, bipolar junction transistor, and junction field effect transistor. Junction field effect transistor. Short form Jfet. So here comparison. First, equivalent symbols. Equivalent symbols. Emitter indicated by arrow mark and base. This is emitter, collector, base. Emitter arrow mark. But JFET has a 3-terminal. One is drain, one is source, and a gate. Okay. So arrow mark outside is called the NPN transistor, and arrow mark inner side is called PNP transistor. So in JFET, arrow mark outside is called P channel. Source, drain, gate. This is P channel. Means here substrate material, P-type material. Here substrate material is N-type material. So this FET is called N channel. These 2 differences with respect to equivalent symbols, and terminals in transistor are Bjt, emitter, base, collector. Emitter, base, emitter, collector. Here emitter is emits the majority of charge carriers. Collector collects the majority of charge carriers. The base acts as a mediator. It's receiving from emitter, transmitted to collector. So base acts as a mediator. But in JFET, allows the majority of charge carriers from source leave the charge carriers from drain. Here flow of charge carriers or flow of current from drain to source controlled by gate voltage. That is called field effect. So this is first point. In second one, input resistance. Second point is input resistance. So BJT input resistance is very low, but in JFET input resistance is high because BJT input resistance in between base to emitter junction. Base to emitter junction every time in forward bias. That's why which junction going into the forward bias, that resistance is very low, less than 100 ohms. But in JFET operating in deflection mode. So gate to source reverse bias. So gate to source act as a high resistance because which junction is going into the reverse bias, it's act as a high resistance more than 1 mega ohms. Third point, biasings. So in BJT, we are using fixed bias, comma, collector to base feedback to base feedback bias and voltage divider bias. Voltage divider bias. But in BJT, self bias and voltage divider bias. And fourth point, operating region. Fourth point, operating region. Operating in BJT, transistor working in every time active region. Okay, here we have three regions. One is active region and the saturation region, cutoff region. But we are operating in every time active region only. But in JFET, we have ohmic region, comma, pinch off region and breakdown region. But we are using pinch off region. Here pinch off region nothing but saturation region. So BJT operating in active region, JFET operating in saturation region. Fifth point, thermal runway. Thermal runway in BJT. Thermal runway done by the at high temperature. High temperature, right? But in BJT, no thermal runway. No thermal runway. Sixth point, type of device. BJT act as a current controlled device. Current controlled device. Because collector current every time depending on the base current, or output current depending on the input current. So BJT act as a current controlled device. In JFET, voltage controlled device. Voltage controlled device. Because here drain to source current controlled by gate to source voltage. So JFET is called voltage controlled device. And terminals. Seventh point, terminals. In BJT, emitter, base, collector. In JFET, source, gate, drain. And input current in BJT every time in milliamps. Input current, millicurrent. Input, milliamps. In JFET, nanoamps. Input current, nanoamps. And the ninth point, applications. Ninth point is applications. BJT, low current application. Low current application. And JFET, low voltage application. Low application. Voltage. These all are 9 points. Comparison of BJT and JFET. Okay. The field effect transistor comparison between the Bjt and Jfet bipolar junction transistor, Bjt, junction field effect transistor, Jfet, and equivalent symbols, base emitter collector. In Bjt, two type transistors, NPN transistor, PNP transistor. In Jfet, N channel Jfet, P channel Jfet. N channel means substrate material, N type semiconductor material. Here gate material highly doped P type. In P channel, P type substrate material, gate material is N type highly doped, and gates two layers internally connected, and biasings base to emitter forward bias, base to collector reverse bias. So JFET working in deflection mode. So gate to source every time in reverse bias, source to drain forward bias. And the second point, input resistance. BJT base to emitter forward bias, so it's act as a low resistance less than 100 ohms, less than 100 ohms. In JFET, gate to source every time in reverse bias, because JFET operated in defletion mode, so reverse bias PN junction act as a high resistance. It is more than 1 mega ohms, and biasings in both BJT as well as JFET operated in voltage divider bias only. Fundamentally biasings in BJT, fixed bias, collector to base feedback, voltage divider bias. In JFET, self bias and voltage divider bias. Fourth point, operating points. So BJT has three regions: active region, saturation region, cutoff region. Maximum transistor operating in active region only. If operating in saturation or cutoff region, half of signal going into the clip. In JFET, operating in saturation region, but it three regions: ohmic region, pinch off region, breakdown region. In ohmic region, current linearly increased. In pinch off region, current is constant. In breakdown region, current going into the suddenly high. So JFET operated in saturation region. Fifth point, BJT thermal runway depending on the temperature. If temperature is increasing, thermal runway occurs. But in JFET, no thermal runway. And the sixth point, transistor is called current controlled device because output current controlled by input current. So BJT is called current controlled device, and JFET output current controlled by input voltage. That's why JFET is called voltage controlled device. Seventh point, terminals in BJT: emitter, base, collector terminals. In JFET, source, gate, drain. Here emitter, base, collector emits the majority of charge carriers by emitter. Collector collect the majority charge carriers. Here base act as a mediator in between emitter to collector. Here source in JFET, source enter the majority of charge carriers. Drain leave the majority of charge carriers. Gate is controlled the flow of charge carriers. Eighth point, input current in BJT milliamps or microamps. But in JFET, input current is nanoamps. And applications, ninth point, applications, BJT low current application. BJT low current application, JFET low voltage application. Low voltage application.
This conference will now be recorded.
JFET biasing circuits. Junction field effect biasing circuits. The three basic field effect biasing circuits: gate bias or fixed bias, self bias, and voltage divider bias. In performance to the three basic BJT biasing circuits: base bias, collector to base feedback bias, voltage divider bias. Now first one is self bias. JFET self bias. First biasing is self bias. In self bias circuit, gate source bias is provided in between VGS by the voltage drop across a resistor in series with the device source terminals. JFET must be operated with reverse gate to source bias, and N channel circuit is, you know, this JFET 3-terminal device. Okay, here VDD positive, VDD connected to the drain. This resistance is called RD. Here applied voltage plus VDD. VDD means voltage applied at drain terminal. So positive potential. And gate to source every time in reverse bias. So through the RG. Here gate source connected to one resistor. That resistor is called RS, source resistance. and the gate resistance is called Rg, and this negative resistance extent connected to the ground. This ground is called VSS, negative source. This is N channel Jfet, arrow mark inside. Here N channel Jfet. N channel means substract material is N type material. Here gate is P type material. So P material is connected to ground. Ground nothing but negative potential. So here gate to source voltage is called VGS. VGS in reverse bias, reverse voltage. Okay, and here input Ig is equal 0 volt current, and VGG is equal to 0 volts, and here flow of current is called ID, nothing but drain current. Drain current flowing through the RD, and drain to source voltage is called VDS. Okay, drain side is positive, source side is negative potential, and across the RS voltage is called VS, voltage across the source, and total output voltage through the drain from drain to source voltage is called V0, output voltage. And one more important point, dropped across the RD is equal ID into RD, and your source to drain voltage is same. Sorry, current is the same. ID almost all equal to IS. Okay, this is the circuit diagram of self bias. Self bias circuit N channel Jfet. When the drain voltage VDD is applied at the drain, current is ID flows. In the absence of VGG is equal to 0 volts. The voltage drop across the resistor RS given by VS is equal IS into RS. But here IS almost all equal to ID. So here written as a ID into RS. Okay. This voltage dropped, reduce the VGS, reduce reverse voltage for Jfet operation. Next, feedback resistor. RS is called feedback resistor. It prevents variation in the FET drain current. The drain current, drain voltage VD is equal VDD minus ID into RD. The drain to source voltage VDS is equal VD minus VS, and VDS is equal VDS is equal VDD minus your ID flowing through the RD plus RS into ID. Okay, and the gate to source voltage input side. This is output. In input side, VGS is equal VGG minus Vs, that is equal 0 minus ID into RD. Okay, so VGS is equal minus ID into RD. When drain current increasing, Vs also increased due to this reverse gate source voltage increases, which decreases the effective width of channel and hence reduce drain current. IDQ is equal, ID means drain current, Q for operating point. IDQ is equal, ID is equal IDSS into 1 minus VGS by VP whole square, that is equal IDSS into 1 plus IDRS by VP whole square. This is self bias. Next, voltage divider bias.
This conference will now be recorded.
Now, Jfet biasing, voltage divider bias. In voltage divider bias, we are using 4 resistors, 1 supply and Jfet. In circuit diagram, Jfet biasing, voltage divider bias, voltage divider bias circuit. We are using R1, R2 and RD, RS, 4 transistors, 1 Jfet. So circuit diagram is Jfet, drain, source, drain, gate. Arrow mark inside, nothing but N channel Jfet. So RD connected to drain and R1 connected to VDD to gate terminal and R2 connected to gate to ground. Here RS connected to source to ground. This ground symbol is very, very important. Here minus VSS. So here plus VDD. So positive potential applied to drain, negative potential applied to source. and VDD to drain resistance is called RD, and source to ground resistance is called RS, source resistance, and R1 in between VDD to gate and R2 gate to ground. Across the R2 is called VGG, gate voltage, and gate to source voltage is called VGS, negative, positive, and drain to source voltage is called VDS, and across the RS voltage is called VS, and across the RD is called VD, and here flow of current ID, drain current, and flowing through the RS is called IS, source current. So source current almost all equal to drain current. So this current is called ID. Nothing but note here, ID is equal IS. Okay, this is the voltage divider bias circuit. Now source voltage is equal to BS is equal to ID into RS. Again here note down in bracket, IS is equal to ID. Gate voltage, gate voltage VGG is equal to VDD into R2 by R1 plus R2, because VGG across the R2, and applying KVL to the input side. Note down, applying KVL at input side, VG minus VGS minus VS is equal to 0. Incoming voltage equal to outgoing voltages. Now VGS is equal to VG minus VS. Okay, that is equal to VG minus ID into RD. VS is equal to ID into RD. Now VGS is equal to VGS is equal to VG minus ID into RD. This is input voltage equation, because output current or drain current controlled by gate voltage. So input voltage is compulsory. But in BJT, input current because BJT acts as a current controlled device. Next, applying output side, applying KVL at output side. Now equation VDD minus IDRD minus IDRS is equal to 0. Now VDD minus IDRD minus VS just a minute. VDD minus IDRD minus VS minus VDS is equal to 0. Now VDS is equal to VDD minus IDRD minus, here VS is equal ID into RD, sorry, RS. Now VDS is equal to VDD minus ID common, here RD plus RS. This is output voltage, complete equation. And the Q point. Q point means operating point. Q point or Q-cent point. So Jfet operating point, VDS Q, Q for operating, is equal VDS Q means VDD minus ID into RD plus RS, and IDQ is equal IDD IDSS into 1 minus VGS by VP. Here VP means peak voltage. Okay. Example, output characteristics in between VDS versus ID, and this is the load line, maximum VDS to ID. So on load line, center point to x-axis is called VDSQ, and on y-axis IDQ. So this is called Q point. Q point nothing but operating point. Okay. Next, fixed bias.